Hello everyone, welcome to our class in Algebra 2 today. As I promised to you, I'm here recording the video. I hope you can enjoy and learn more and more and more. Okay, let's go over here our class in Algebra 2. Guys, as I promised to you guys, here is our lesson. This is the review first. Okay, we started with this. 3 squared is the same thing as write 3 times 3, which is 9. X plus 3, as you remember, is x plus 3 means x plus 3 times x plus 3. Distributive property, x times x squared, x times 3, 3x, another x times 3, another 3x, and 3 times 3, which is 9. Combine like terms. The like terms have those 3x here, which is x squared plus 6x plus 9. Done. Guys, can you see here the number 3 is the same? X plus 3 to the second power. Then we don't need to solve again. We did already before. What do we need to do? Just multiply by 4 everything in parentheses. Let's multiply by 4 everything, which is x squared plus 6x plus 9 times 4, 4x squared, 24x, and 36. Great, this is the first. Let's go, guys, in our lesson, the page number 2, over here, the first scenario. I think you remember this last class, where I talk about the Miriam Tile Company. The second one, it is the students' work about talking about the homecoming king election, like they're spreading a gossip over there about the results. And number 3 is just another pattern to construct a patio. Okay, over here. Let's describe the growth for each scenario. The scenario number 1, guys, as you notice, design number 1, 1. Design number 2, it is adding 8 plus 8. Design number 3, the green one is adding 16. Great. This is the growth of the scenario. We're just describing the growth of the thing. And the second one, it is times 2, because each student share with the other 2 students. Over here again, times 2, times 2, times 2. It's the new students know about the gossip over there. And over here, guys, if you notice, it will have like something is permanent, like the entrance and the exit is always the same. Then it is 2 plus 1 times 3, which is 5. The second one, the 2 plus is the same. 2 plus 2 times 4, which is 2 plus times 4. Oh, let me erase this thing here. 2 times 4, 8. 8 plus 2, 10. And the third one, it is 2 plus, now 3 times 5. 3 and 5. 3 times 5, which is 17. Okay, just describe each pattern, the growth of each pattern. That's the first question. Question number 2. Describe how the quantities change relative to one another. The first one is adding 8. You see? Adding 8, adding 8. The second one, multiply by 2, multiply by 2, multiply by 2. The third one, the 2 is permanent, okay? But it's adding 1 in each edge of the rectangle, okay? Add 1, add 1. Add 1, add 1, add 1, add 1 for each new pattern. Okay? So far, nice. Over here, guys, using patterns to build expression. Now we're building expression. We're converting the words we learned so far in math. Okay? I'll just show up one example here because number 1 and 2 is ready for the next question in future, okay? I will just not solve those page here because it's exactly the thing I'll do in future over there. Okay, for example here, write an expression to represent the number of new tiles. It's okay, we know that already. The other one here, about the each pattern over here. Let me go explain to you this first one here, the Miriam pattern. Describe the pattern of new titles an employee must add to each design in this. Is the pattern linear, quadratic, or exponential? Guys, it's adding 8. Adding 8 is linear. If you make a graph, you will notice it's linear. Then it is linear. Okay? Question 2. Write an expression with the number of new tiles that an employee must add to n times n squared. Guys, this one, I will take a while to solve this one, but I'll try to solve here. Here's my first pattern, yes? Everybody understand? One way to do is several ways to solve, okay? Several, but I just pick one. It's like this, add. This is my n tile, okay? This is an n, another n, another n, and another n. N plus n plus n plus n. How many n's do I have? 4. It is 4n, but this is not a square yet. Oh yeah, that's true, mister. How to make it become a square? Let me just add on the edge which number? 1 on the corner, 2, 3, 4. Oh, 4n plus 4. This is the general equation for the new adding pattern we have over here. And describe which values for n make sense in this problem situation. Guys, to have this exactly pattern Miriam is working, I only can solve this using the edge. I never will be even number. Because if the edge is even number, we don't have this central tile over here. Never. Okay? We only have the central tile if we have odd numbers on the edge. Okay, always we're working with odd numbers. Great. In this problem here, guys, is more. I like this one because it's more. It makes the thing easier to understand the problem. Okay, we're talking about the Miriam's problem over here. The expression 8n minus 1 upon Miriam's square floor pattern. I noticed that the number of new titles increased by 8 in each new design. Explain why Ramona's expression is incorrect. Guys, pay attention here for this pattern. Design number 1. Design number 1 is 1 tile in the pattern. 1 tile in the pattern. When we have 1 tile on the edge, 8 times, 1 minus 1 is 0. 8 times 0, 0 new pattern, new tiles. Okay. The first one, okay. Design number 2. Design number 2 is 3 tiles. 3 tiles. Okay, 3 tiles. 3 minus 1. Oh, but look, he's telling to us design number 2, as you can see here, is number 2. Okay, it's 2 tiles. Do we have 2 tiles on the edge? No. Design number 2, we don't have 2 tiles on the edge. We have 3 tiles. Okay, he's relating the number of designers as the number of the tiles on the edge. Then I cannot use this one. That's why it is wrong. Design number 2, it is 3 tiles on the edge, not 2. Okay, that's why. That's the problem. And here, guys, Miriam asked for some employees to design a new pattern over here. The first one was Vilma. Vilma, she figured out like, I must add 3 tiles to each of the 4 sides. Okay, 3 tiles. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's why. 3 new tiles and 1 tile on the corner is the first thing we did. But we need like a generic expression. Which number we told this is before? It is the n. The n for us is 3. Let's remove 3 and add n, which is 4n plus 4. Okay, next one, design number 5. It is the same thing, but I must add 5 tiles to 2 of the sides. Okay, 5 tiles here and here. That's why it's 5. Okay, and 3 tiles here. 3 tiles here, 3 tiles here. 5, 5, 3, 3. Okay, that's the thing. And you multiply times 2. But remember, which number we moved back was number 3, yes? Then let's remove number 3 here and add an n. 2n plus 2 plus 2 times n. Oh, this is the second expression. The third one, the 3's, we just remove the 3's and add n plus n plus n plus n plus 4. And the last one, guys, as you see here, Tamara is a little bit different because she like find the total minus the previous one. That's we have just the corner, that's the edge of the thing, which is a good idea. But remember, let's write a number 5. Instead of use 5 times 5, let's use which number can use for write 5 using 3? Is 3 plus 2. Then it is 3 plus 2 times another 3 plus 2 minus 3 times 3, which is 3 squared. Remember which number we're moving back? Number 3. Let's write here, it is n plus 2 times n plus 2, great, exactly the same, minus n times n. How do you write that in math? Oh, it is n plus 2 to the second power minus n squared. This is a different way, different approach for the thing. Question 6, guys. Which expression do you think Miriam should use? Doesn't matter. Any expression she uses will work. Doesn't matter. Everything over here, guys, as you notice, will work because all of them give to us the total tiles we have over there. Great. And let's go over here. Next question, number 7. Michael and Louise analyzed the expression they wrote. They both determined the expression to represent Tamara's method. Michael claims that his expression is quadratic because of the n squared term. Louise disagrees and says the expression is linear because the pattern grows by a constant amount. Who is correct? Guys, who is correct is Louise. Why, mister? Let's just open up. Let's solve this the equation here. It is n plus 2 squared minus n squared. Let's solve this guy here, distributive property, which is n squared plus 4n plus 4 minus n squared. Oh, combine like terms. Goodbye, goodbye. What is left over? 4n plus 4. Linear. Okay? Guys, question number 8, as you can see here, is just apply all 4 methods in this quantity of tiles on the edge, which is 135 by 135, and to see how many tiles if it's so for everything. If you use anything, it will work. Okay. And question 7, page 9. Sorry, question 9. Wilma tells Miriam that since all the expressions result in the same resolution, the employees can use n of the expression to determine the number of additional tiles. Miriam thinks that the employees need to use more values in the expression than just one to make this conclusion. Who is correct? Guys, Vilma tells you we can use anything, and Miriam told you we need to make more expression to do this. Guys, Miriam is correct. Why? Because she thinks that the employee needs to use more values in the expression than just one to make this conclusion. Okay, we need to explore more. The employees know that thing, but we need to see if it works all the time. Okay? And question 10, just recall that 2 or more expressions are equivalent when they produce the same output for all input values. You can verify that 2 expressions are equivalent by using properties to rewrite the 2 expressions as the same expression. It's the same thing we did before, like solving that 1n squared, remember, n plus 2 squared. Just rewrite that stuff in different way to got 4n plus 4. And you will see that, okay? This is our lesson today. I hope you enjoy. And this is our first video. Try to make it simple, quickly, and fast. Okay? Bye, guys.